I want to start with the 3 laws of thermodynamics. I am aware that there are actually 4 laws, but I'm going to ignore the 0th law and talk about the traditional 3. And then I'm going to talk about how thermodynamics just doesn't work. So let's get on with it. The pessimistic laws of thermodynamics. This was put to me by my original mentor in physical chemistry way back in the early 70s, and here's the way he put it. The first law, you can never win, you can only break even. Pessimistic. The second law, you can only break even at absolute 0. The third law, you can never get to absolute 0. So thermodynamics is inherently pessimistic. It says give up before you start, you're never going to get there. The first statement is actually a statement of conservation of energy. This began, the history of thermodynamics began with steam engines, heat engines, trying to understand them, trying to make them more efficient. This first law was derived to describe heat engines, but it was quickly generalized to other areas of science, and over the intervening decades, even centuries, it has become a bedrock foundational concept that is never challenged. However, when you get into physics more deeply, you find that there's some intrigue behind this conservation principle. First of all, let's state the conservation principle explicitly. Energy may be transformed from one kind to another, but it cannot be created or destroyed. The total energy is constant. COE, conservation of energy, is my abbreviation for it. This principle is most clearly true in what are called adiabatic systems. That is, artificially constructed systems in which no energy or matter can enter or leave the system. In these systems, we can experimentally determine that indeed energy is conserved. And these systems are called closed systems. I want to emphasize closed systems. Generally, when we generalize this principle to the entire realm of science and the universe, we consider it to be true where the entire universe is considered to be a closed system. That's another key concept that I'm going to try to destroy. The great physicist Richard Feynman, one of the greatest physicists of the 20th century, had this to say about the law of conservation of energy. There is a fact, if you wish, a law governing all natural phenomena that are known to date. Note that qualification, that are known to date. The law is called the conservation of energy. That is a most abstract idea because it is a mathematical principle. It says that there is a numerical quantity, which does not change when something happens. It is not a description of a mechanism or anything concrete. It is just a strange fact that we can calculate some number, and when we finish watching nature go through her tricks and calculate the number again, it is the same. So Feynman considers conservation of energy to be very abstract and very strange. Well, since I'm now entering philosophy as my third field, I need to quote a couple of philosophers. Philosophers of science. Start with Dr. Karl Popper. He is the biggest proponent of a concept called falsifiability. He insisted that a theory is not scientific unless it is falsifiable. One of the most horrid words I've ever run across in my entire life. What it means is not what it says, but rather a theory is falsifiable if it is at least conceivable that an experiment can be designed that would have the potential to demonstrate that the theory is false. Not that the theory is actually false and therefore valid, which is what the word would suggest. Well, another philosopher of science, Dr. James Ladyman, which is one of the great names in all of science and philosophy and history, Dr. Ladyman says, quote, "Some unfalsifiable principles may nonetheless be rightly considered part of scientific knowledge. It is inconceivable to most scientists that an experiment could falsify it," meaning conservation of energy, An apparent violation would reveal instead that something is wrong with the rest of science. In other words, scientists won't question the conservation principle. They'll go look for something other than it to fix so that they can save the principle. Well, I'm here today to destroy the principle. So I guess I'm going to be claiming that there's something wrong with the rest of science, according to Dr. Ladyman. So I want to use a dirty term, string theory. I already know that Henry Bauer and York Dobbins are not fans of string theory. It is, in fact, very controversial. It's not really recent. It has a history that goes back at least to the 70s, but it has only become popular, famous, really, in the last couple of decades. String theory proposes that the most fundamental entity in the universe is energy, and that it's manifested in two forms, the closed loop string and the open-ended string. Notice the closed loop string is self-contained, but the open-ended string has a couple of ends, a couple of loose ends that need to be tied up. So, string theory proposes that open strings are tied up by being attached to what's called a D-brane, and this is a, let me use my red pointer. Can you see the red? The red on red here is the D-brane. That's reduced to 2 dimensions from 4 dimensions, 3 spatial and 1 temporal dimension. And an open string must be affixed by at least one end to a space-time, in this case a 4-dimensional space-time. Whereas a closed string needs no such attachment. In fact, it cannot form any such attachment. And so we have a situation where one is constrained, that is, open strings are constrained by being fixed in a space-time, whereas closed strings are free. They're free agents, they're free floating, they can go anywhere. They can be in a 4-dimensional space-time, but they can also leave it, they're not attached to it. That means, first of all, that closed loop strings do have the exclusionary property of matter, what philosophers called extension. Closed loop strings do not have extension, they do not occupy space in an exclusionary manner, although they can exist within 4-dimensional space. They are not excluding other objects from that same space, so to speak. So string theory says that these are the 2 basic components from which everything else is constructed. Now again, I will say, string theory is controversial. It has not been proven. Some scientists believe it's unprovable and therefore not scientific. That is the Popperian view. It's unfalsifiable, so it's not science. I'm going to argue that in fact it is falsifiable and it has not been falsified due to billions of experiments. Pretty outrageous. Closed strings should be able to form entities by interacting with each other, just as open strings do. There's no a priori reason why this is impossible. So, is it possible to conceive of a closed string body, a closed string entity? I'm going to suggest to you that what you're looking at right now is a picture of a closed string entity or body. And no, not the entire closet that you see there. I'm going to have to point out the entity to you. It's a little hard to see, but it's right there. Do you see it? This is what is called in parapsychological circles an orb. And at past SSE conferences, when I've mentioned orbs to people, they've pulled out their laptops and shown me their collections of pictures of orbs. And I'm like, well, you're way ahead of me on the orb front. This is the only picture I have of an orb. And this was given to me by a friend who was a ghost hunter, a part-time amateur ghost hunter. She was investigating her mother's basement, and she announced to no one in particular, if there is anyone here who would like to reveal themselves, please do so now. And she took 3 consecutive digital frames The first and third revealed only the closet. The middle one showed this white entity in the frame. So it showed up at her request and it disappeared. It didn't come from anywhere, apparently, and it didn't go anywhere, apparently. It just popped into this reality and popped out. This, I'm going to suggest to you, is a closed-loop string entity, otherwise known as a ghost, also otherwise known as a disembodied human spirit. So, I'm suggesting that we, as spiritual entities, are composed of closed strings, and we can pop in and out of this universe when we're not tied to a body. String theory is consistent with this picture. If you don't like string theory, you can at least think of it as a way to conceive of these things as having some kind of physical basis. If you reject that, well, you reject my talk, which is okay. But why would I think this? Well, it turns out I've got empirical evidence from the near-death experience. And this is where another connection comes in. NDEers are people who have experienced near-death experiences. So from Raymond Moody's initial book in 1975, which is rich with descriptions, it's short on science, but it's rich in descriptions, he quotes people who were out of their bodies, and he asked them what they were like, what their selves were like when they were out of their bodies. And here are 3 quotes. First, the person described being composed of waves and being charged. A second person described being an energy pattern. And a third person described being a little ball of energy. And if you'll think back to the closet picture I had just before, doesn't that seem like a little ball of energy just on the surface of it? This gives me the idea that, in fact, the human spirit has an energetic nature or an energetic basis, and it's composed of something that's not tied to this universe other than by interactions with the body. So when you're out of your body, you're free to go. Where would you go? You might go through a wormhole. This is the relativistic wormhole predicted by general relativity. It's one of the solutions to Einstein's equations, one of the many solutions along with black holes. And it suggests that, I never can find my red dot. I'm going to do it without the dot. It suggests that we can traverse from one area of space to another, but relativity explicitly says that the topology of the 2 surfaces connected are not determined by the presence of the wormhole. So those 2 surfaces can wrap around and connect with each other, in which case the wormhole is a shortcut from one place to another in this universe, or the 2 surfaces can be completely disconnected, which means the wormhole represents a pathway from one universe to another parallel universe. I'm suggesting that in the near-death experience, this is what happens, the second case, that the disembodied closed string entity travels through a wormhole, the NDE tunnel, as it's called, to another parallel spacetime, which has been described in great detail by many NDEers. In fact, the tunnel itself has been described. Here's one description. I do remember thinking to myself that I was dying, and I felt I was floating through a tunnel. When I say tunnel, the only thing I can think of is, those sewer pipes, those big pipes they put in. It was round like that, but it was enormous. I really couldn't see the edges of it. I got the feeling that it was round. Another case, the first thing I remember was a tremendous rushing sound, it's very hard to find the right words to describe. The closest thing I could possibly associate with it is possibly the sound of a tornado, a tremendous gushing wind, but almost pulling me. And here's the key part, and I was being pulled into a narrow point from a wide area. Think again of the wormhole diagram. The interviewer says, sort of going into a funnel, and the NDEer says, yes, yes. And it was nothing painful. There was nothing frightening about it. It was just something I felt I gave myself into and completely. And it felt good. A third case. I felt as though I was, well, that's the hard part to explain. Like you're floating, like you're there, and believe it or not, the color is, there is no color. It's like a darkness. The interviewer asked, did the darkness have a shape of any kind? It was empty, which is not answering the question. Yeah, that's it, space, just nothing. Nothing but something. It's like trying to describe the end of the universe. There's the key phrase. So think back to the diagram of the wormhole. Would entering the wormhole be like leaving the universe? That's exactly what it would be. So these in the ear descriptions are commensurate with a closed string energetic body that travels through a wormhole to a parallel universe. Outrageous stuff, I know. But here's the point. If closed loop strings are composed of energy, then they are constantly leaving this universe through wormholes. Others, I'm proposing, are constantly entering this universe through wormholes. That's how we come and go from this plane of existence. Furthermore, string theory in general, M theory, the most advanced form of it, says that there are 11 total dimensions, 5 of which are spatiotemporal, 4 spatial dimensions and 1 temporal dimension, and the remaining dimensions are curled up and inaccessible to us. In that case, string theory and relativity are making the same prediction that there is a 5th spatial, extended spatial dimension. That means that not only are we losing energy and gaining energy by exchange through wormholes, but other energy in the form of gravitons is leaving the universe through the other curled up dimensions. In other words, energy is not conserved. It's constantly leaking out of and into this universe. And so let me go to my summary points. Energy leaks from this universe in the form of gravitons, not bound by our space-time. Energy is exchanged between this and a parallel space-time in the form of closed string bodies that are the seat of consciousness. That's from the NDE. Our space-time, therefore, does not constitute a closed system in the thermodynamic sense. We can no longer say the universe is a closed system and save the conservation of energy through that mechanism. Further, conservation of energy therefore cannot apply to the universe as a whole, nor to consciousness at all. And please note that conservation of energy historically has been one of the objections to substance dualism as an explanation of mind-body nature or interaction. So this destroys that objection. Similarly, conservation of energy cannot be applied to large mass systems, although this has not been tested. And remember Feynman's statement, the natural phenomena that we are aware of to date. Well, now we know more than we did when Feynman was alive. Hence, conservation of energy should be seen as a useful approximation, but only for small mass systems and inanimate systems, that is, systems without consciousness, because I believe that consciousness has its origins in closed strings that are not necessarily conserved in this universe. So, that's my talk. Thank you very much.
I've spent a lot of time analyzing UFO data, including pictures of orbs. Just one thing sprang to mind. Whenever you see a fuzzy, faint orb, look diametrically opposed in the photograph for a bright light. Sometimes there's a lens reflection that goes over to the opposite side, and sure enough, in this photograph of the closet, down in the lower left was the brightest thing in the lower left was a bright light, the brightest thing in the frame, and diametrically opposed was a dim light. Maybe just point it out.
My question involves detection. So if mass is not, if energy is not conserved, then perhaps mass also is not conserved. and then there's a mass associated with any energy divided by c squared and all that. So just as we can build detectors, and people have built detectors to detect the standard spin 2 gravity waves, it ought to be possible, I suppose, to build a detector that could detect these, what would you call it, scalar gravity wave that would occur when a mass suddenly appears. You have any thoughts about that?
No, you blew my mind there.
Okay, thank you.
I can't comment on that productively at all, sorry.
Yes, I'd like to comment that you're actually not refuting energy conservation at all. You're simply extending the size of the system that we have to refer to as the whole universe. I do have an issue with the whole going through a wormhole notion, however, because there's nothing magical about a relativistic wormhole that would make it only accessible to closed strings. If there were one or many large wormholes in the vicinity of Earth, we would definitely have noticed by now.
I happen to disagree with you very strongly on that point.
I'd like to add to what the first questionnaire said, which is describing a lens flare, but there is another mechanism where you can produce these orbs.
Even standing here, I can't hear you.
Okay. There's another mechanism. Oh, wow. Okay. There's another mechanism where you can produce orbs. In my research, I track a phenomena called earth lights, which often precede large earthquakes. And so I've done a lot of photoanalysis and debunking my own material, a lot of it. But what can happen is that dust that's about 18 inches in front of the camera's lens can reflect the flash from the camera. And dust is everywhere, and oftentimes we see a person with a beard that is surrounded by orbs or wearing fuzzy clothes. And so what happens is I think that you have to be very careful in the interpretation of an orb and really do a very concentrated analysis and rule out, because I've taken a dust cloth and shaken it in front of a camera. I've taken a squirt, spray, and you can produce these orbs. And so I suggest that maybe you do that and compare that to some of your photographs.
I'd be up for that.
Thank you. Thank you very much for your talk. It really meant a lot to me. I'd just like to say about orbs that from being very skeptical, I was completely turned around on going to the Festival of Sacred Music in Fez, Morocco. And on looking at my photographs when I got home, flash photographs in a huge auditorium, open air, it was loaded with orbs, and many of them were colored. Now, since then, I've done a lot of control experiments, and with water spray and fungal spores and things like that. They're never colored. And the other example I quote, I went around local churchyards at night, and in the oldest one, the old Saxon churchyard, the orbs were there, and they were colored.
I've seen pictures like that too.
Yeah.
I had a question why you used gravitons to be the source of this energy leakage. It's sort of an imaginary particle no one's even found. Why did you choose that?
Well, it wasn't me that chose it. It was string theorists who chose it. And yes, they have not been found yet. But about 3 years ago, the Higgs boson had never been found, and now it has been. So I guess I'm relying on future physics to come to a conclusion that these things are real. And if it concludes that they aren't real, forget what I said.